Hello, this is Calculus 2 on April 15th, 2020. Used to be tax day, but all the rules are off these days. Anyway, I want to do an example of polynomial long division in the partial fractions section. So we have a fraction like x to the fourth minus 3x squared plus 7 over x cubed plus 2x squared. Let's say we want to integrate this. What a nightmare. Don't even think of going trigonometric substitution, not necessarily. We can't break this into partial fractions just yet because the numerator is an x to the fourth, and fourth is greater than or equal to the power of the bottom, so polynomial long division can be done. Now don't forget, it is x to the fourth plus no x cubed minus 3x squared plus no x's plus 7, all being divided by x cubed plus 2x squared. A lot of people get them mixed around. The denominator is what is dividing. Okay, next of all, it's almost a little bit easier than regular long division if you get the hang of it. Because what you're saying is, how many times does x cubed go into x to the fourth? That is to say, what do I need to multiply x cubed by to get x to the fourth exactly? And what I need to do is I need to multiply by just x. And if I multiply, I get x cubed times x is x to the fourth, as we want. And 2x squared times x is 2x cubed. Now, we subtract this. About half of the mistakes that people make with polynomial long division is subtracting incorrectly. So what I do is I change the signs of both of these things and then add. And if you did it correctly, the x to the fourth plus negative x to the fourth is gone. And then the 0x cubed plus negative 2x cubed is negative 2x cubed. Now, we can still go one more step. We can say x cubed times what is negative 2x cubed? That would be negative 2. X cubed times negative 2x cubed is negative 2x cubed, and 2x squared times negative 2 is minus 4x squared. And again, I change the signs. I change both of these negatives into positives, and then I add. Changing the sign of something and adding is the same thing as subtracting. Negative 2x cubed plus 2x cubed is gone, and this is a plus 4x squared. But there was a minus 3x squared, so minus 3x squared and 4x squared is just positive x squared, and we bring down everything else, the 7, because we're done. We could go into fractions. We're not going to go into fractions. This is our denominator. So what we've said is, if I take x to the fourth minus 3x squared plus 7 and divide it by x cubed plus 2x squared, the whole amount is x minus 2, and then our remainder is the numerator of our fraction, like with a regular thing. So x squared plus 7, all still yet to be divided by x cubed plus 2x squared. Now again, I said partial fractions. This denominator is, we can factor out an x squared times x plus 2. And so this is going to be x minus 2 plus partial fractional decomposition. We get each power of each of our factors, our two factors are x and x plus 2, gets its own fraction, a over x, and then the next power of x squared, b over x squared, and then the x plus 2, that's linear. The highest power is x equals 1, so we're going to have a highest power of x equals 0, 1 less, which is just a constant, c over x plus 2. Now, I haven't quite, in the notes that I've been typing up, gotten to how to find the a, b, and c, but that technique won't work if you have a higher power like x to the fourth over x cubed. But this polynomial long division will always get you down to a numerator that is of smaller degree. So hopefully that explains that.